So we have to start about software interrupt instructions. So basically, remember SWI. Software interrupt instructions are denoted as SWI. So these are the instructions which are executed to to generate a software interrupt or in exceptions. So if you want to generate an what is that interrupt or exceptions for the software, you use this SWI instruction. Software interrupt is SWI instruction. So software, let me just highlight it like this. Software interrupt. Okay, so syntax is SWI and SWI number. What is a SWI number? It's a unique identifier for a system to call a function. So you basically, why you are this instruction is used to generate exception or interrupt. Why are you doing that? It is because it allows the user application to call operating system routines. So basically, calling for system calls. Okay, used for system calls in OS. So to call that system call, you need a unique identifier. So that's why it is being used. Optional conditions for sometimes this is not required, but sometimes it requires optional, right? Execution steps. How SWI instruction is executed. So when SWI is executed, so these things happen. See what the processor saves the address of the next instruction in link register underscore SVC. You can just write link register, but for better example, you have to mention underscore SVC because you're storing the address in supervisor mode. So basically what I have to say here, so some instruction I is being performed. So the next instruction, so IN, this instructions is stored into the PC. PC of what? Supervisor FCC mode. You have already studied about different modes in the first model, right? That's what is happening. And then the CPSR is saved into the SPSR of supervisor mode. Then the program counter is set to vector table. Yeah, I have to write LRO here. I wrote PC by mistake. Sorry. The program counter is set to vector table. Always remember. So vector table is at 0 into 8. Yeah. Oh, see, it's already over here. Then processor mode changes to SEC. Whatever mode it was, then it changes to supervisor mode. Then interrupt requests are marked in the sense interrupt requests were 1. Now they are disabled to 0. When it is executed, in the sense what? While execution, when it is occurring, first it is marked to 1. Since it is executed, now it is 0. After the execution, what are all the states which are changed? So now uh, this has changed. What happens? So basically it was in some mode. Now it is changed to what is the supervisor mode. So address of the instruction following SWI is changed. SPSR underscore SVC. This is changed. CPSR is changed to supervisor in the SPSR. Then PC is changed to vector updated state. CPSR mode is changed to supervisor mode. Then CPSR IRQ is equals to 1 in disabled. Okay, so it's ulta. If it is 0, it is enabled. If it is 1, it is disabled. Okay, example how they have used. See, SWI number is 123456, commonly used for debugging in ARM toolkits. So here CPCR is equals to, see, this is the condition flags. What is this? Negative, zero, carry, overflow. This is the saturation. What happened? Saturation. I is that interrupt, fast interrupt request, thumb bit. Okay, which is in user mode. Program counter before execution. After execution, this will go to vector table 1. Link register is 0 into 003 5 times f. Previous value, previous return address. Like the last instruction might have returned some address, right? Then R0 is the parameter via R0. So 0x12 is a parameter via base register. So what is the instruction? SWI with SWI. What is this code? What do we call this? Unique identifier, right? So now what happens? This is same. Here it was in user mode. Now it is in which mode? Supervisor mode. See, and now here SPSR at this saves previous. So now see, SPSR. Okay, so CPSR, current CPSR is stored to SPSR, right? So we studied over here, whatever the CPSR is there, it is saved into the SCSR supervisor mode. So that was happened. Program counter is now, see, Before execution it was here, this 8 has gone to this place. Okay, and then link register, here 4 has come, just like that. So how to handle this SWI calls? The OS or SWI handle processes the SWI call. The SWI number is extracted using the instruction address store LR. First, it is handled by either the operating system or by the handler, and the address is updated to the with the help of link register. Formula, SWI number, instruction and not this value is given. The mask output, so if you see this place, first handler is handling it. First it is storing the register into the link register, all the address, see, then reading it, popping out, and then you have to mask the top 8 bits using the bit clear function, and now it contains the SWI level. By using the service routine you can see it, then it returns, pops out, loading, right? So you can see it's just an explanation. If you just read out, it will be very helpful for you to understand. Application, so you have operation system calls, or system calls, just system calls. Debugging and exception handling, using the SWI number, it are used for debugging operations. Secure and privilege mode allows user to execute privilege operations via system calls, like going to supervised mode and all stuff. So program status or register instructions. So this is the next one, we will do it in the next video.